So this video refers to Lecture 6, Structural Analysis, and it's specifically the first video, an introduction to structural analysis. So during the videos, there'll be 4 or 5 videos on this. We'll look at a simple truss, looking at the forces of a truss, then looking at zero force members, and then solving the forces in either all the members or certain members using both the method of joints and the method of sections. So if you refer to slides 3 and 4, slide 3 shows some simple truss structures like those used to support roofs or stadiums in for sports arenas. So you've just got beams that are in triangular arrangements, so they're very lightweight but very, very strong. And similarly on slide 4 you've got cranes and transporters, very lightweight but able to support large loads. And then the first real equation that's of interest is how many members you're going to have in your truss. Well, the number of members you're going to have, the number of beams, is going to be twice the number of joints minus 3. That's assuming a simple triangular structure. One thing you should note that is kind of implied on slide 5 is that we're only dealing with 2D trusses here. Although that equation will hold assuming we're using tetrahedral structures in 3D. You'll only be dealing with planar 2D trusses with triangular element sections. But another key thing we're going to have to think about is what is happening in each member. So for instance, I've got 3 members. Are they in tension or are they in compression? That's going to be a key thing that you're going to think about. And it's key for the design of the truss because obviously materials behave differently in tension or compression. If we consider just one member to start with, and we imagine there was forces acting on it, like this. Now, obviously, both the forces are acting outwards, so it's being stretched, so we'd say that's in tension. And similarly, if both the forces acting the opposite way, then it's in compression. Now that's if we're just considering a member, so that's a single member. You can't have the forces one acting up, one acting in one direction and one acting in the other. For instance, you can't have that because then it would move, it wouldn't be in equilibrium. So that we don't have in statics. But when we're considering what's happening at a point, if that's a pin joint, and we've got a member, it's pinned here as well, we're going to be considering maybe the forces acting on that joint. Well, if the force is pushing on that joint, then the joint is also going to push back on the force, on the member, sorry. So in this instance, where you've got it pushing on the joint, we call that compression. And in the other instance, where you got it, the force from the joint pushing that way, pulling away, then we call that tension. And if you imagine that's like the member is trying to pull away, so the member is trying to move that way, but it's pinned down. Well, that's going to stretch it. And for the first instance, it's like the member is trying to push against the joint. It's pushing into it, so it's going to compress it. So, of all the bits to take from this introductory lecture, this slide on compression and tension, which way is compression, which way is tension, is key. And it's key to solving method of sections and method of joints. So, something symbolised like that would be in compression. Something symbolised like that, pulling away from the joint, would be in tension. Moving away from the joint, stretching, in tension. That was a very brief introduction to structural analysis. We're going to, over the next 2 videos, look at method of joints and then method of sections for solving specific questions, and then we'll do some some further summary at the end.